Good morning, students. I hope you all are at home. Stay at home, be safe, and in this crucial time, we all are with you and we are trying our level best to reach you with our subjects. So, let's start our chemistry session. So, please do subscribe, like, and share my channel. And if any doubt, comment in the bottom, and whatever you can call me, that you have my numbers. So first, solution. We'll start with solution. I hope you already updated your notes as I have given earlier. So solution. So this chapter is your second chapter, and after reading this chapter, you'll get to know the type of solution, what are the concentration terms of the solution, and again some laws like Henry laws and Raoult's law, which are depending upon the solubility on vapor pressure of a solution. Thereafter, ideal and non-ideal solution, how you will distinguish these solutions. Thereafter, some properties of a solution that belongs to the colligative properties and its correlations, and again abnormal masses of these colligative properties. So take out your copy, sit, relax, sit back, start writing and note it down whatever I'm telling. Okay, so first, what is solution? We all know from the childhood that solution is which mixes, or solution is a type of mixer, right? So if I'll recall that mixture solution is nothing but a mixer, but it is again of two types. From earlier knowledge that we know that it is of homogeneous and what? Heterogeneous. But whenever we will tell about a solution, that always we have to consider that homogeneous solution. Okay, we are not at all reading in your chapter that is heterogeneous solution. We are considering only homogeneous solution. So how a solution is made up of, how it forms. So solution is the mixture of two things, that is what? Solute, and another one is solvent. Another one is solvent. When you add one solute and one solvent, it becomes a solution. So in solution, remember, the property will be different. The solution has itself unique property. It does not bear the solute properties, it does not bear the solvent properties. It will not like that. It has some properties, but the solution has different properties. It will not same as like solute, not same as like solvent. Okay, so there are so many type of solutions depending upon the state of matter. How many states are there? We know that solid, liquid, gas, insane, and 5 states. So basically the important 3 states, that is solid, liquid and gas, in these 3 states we can divide the type of solution in various types. So let us read. So in types of solution, there are hope you are visible. Solution is. So types of solution, this is type of solution. gaseous solution, if you consider about a gaseous solution, the solute and solvent must be your gas, and solute may be a gas, solute may be a liquid, solute may be a solid. So in your NCERT there is a table which is given some example of these. A very easy, that gas solutions means what? Oxygen in nitrogen. We know that in atmosphere is a gaseous mixture where we can say that this is a gaseous solution. Liquid in gas, that is liquid is, suppose chloroform is there, and chloroform in nitrogen, these are the liquid and gas solution. And solid in gas solution means camphor. We know that camphor we are treating inside a cloth, in toilets we are using the camphor. So that is what an example of solid gas solutions. So always remember, in a solution is of solute and solvent. How do you know that whether which one is solute and which one is solvent? The larger part is solvent. Remember, this is important. Larger part is solvent. Maximum part which is solvent. If I will say 10% of glucose solution, that means 10% of what? Glucose. Glucose is the solute because it's only 10%, and the about rest 90 is water because of solution. So 90 is water, means water is your solvent and glucose is your solute. Suppose the ratio is same. Suppose 50% ethanol. If I will say 50% ethanol, that means 50% ethanol, 50 is ethanol and 50 is water. That means in this case you can take both as a solvent. If you take ethanol is a solvent, okay. If you take ethanol is a solute, that is also okay. Suppose your 80% ethanol is there, then the solute will be your water, because the major part is your ethanol. This is how you need to determine. This is very important. During this colligative property, you need to find out the solution, dilute solutions and concentration solutions, concentrated solutions, right? So next, this is how you need to find out the solution types. You can similarly, if your solvent is, the maximum part is your solid, then the solution is called solid solution. If it is liquid, then the solution is called liquid solution. We are reading three types of solutions. One is gaseous solution, one is liquid solution, and another one is solid solution. If your solvent is liquid, or that means the maximum part is liquid, then that is liquid solution. If your solvent part is gas, then that is gaseous solution. If your solvent part is solid, that is what? Solid solutions. Here also you can get the example from your NCERT. If any doubt, okay. So if you proceed next, the concentration terms. So this is all about your type of solution. Next we will go to the concentration solutions. Concentration of solution. So it's a term that defines a solution, the amount of solute present in the solution. That means concentration. What is concentration? Concentration is the amount of solute. Amount of what? Solute present in amount of solution. In a solution, the amount of solute present, that is what? Concentration. If I will say gram, 1 gram per liter, that is what? Gram per liter, that is terms of concentration. So there are so many terms in your syllabus that we have terms like W by W percentage, the terms like volume by volume percentage, again the terms ppm parts per million, your molality, molality. Here it is molarity. Molarity. Again W by V percentage. Okay, so these are all the concentration terms by which we can easily identify a solution, what amount of solute is present in the solution. So these are the basically the concentration terms. We will go thoroughly in details. Okay. So concentration terms I have written in two segment. If you will see here, I have written V by V volume. This is totally volume dependent. This is totally in mass. Here also you can write mole fraction. This is also again a concentration term. Okay. So in these two, these are actually, I have segregated in two types because these are the temperature dependent. Temperature dependent. In competitive exams, they may be asked questions like molality, how you which one is better, like molarity or molality, which one is better? Obviously molality, because it doesn't depend upon the temperature. It doesn't depend on temperature, that is temperature independent. Okay, and these two terms, this is mass and this is volume terms, the correlation between these two is that we already know the density. If you know the density, you can calculate, you can get a relation. We have a relation that between density equals to mass by volume, by which we can easily solve our numericals. Normally the tricky questions that is given in terms of W by W, and you have to find out the molarity. So you have to use this formula to get the answer. Okay. So W by W, that is your weight by weight percentage, and weight by weight percentage means amount of, let me clear the board, temporary board, it is not actually, yeah. So write W by W percentage. W is weight by weight, that is mass by mass percentage. That means the mass of the component, mass of the component of the solution divided by the total mass of the solution, by the total mass of solution into 100. The 100 is due to the percentage. Okay, mass of the component of the solution divided by total mass of the solution into 100. This is weight by weight, because here you can see mass by mass percentage. Easy. Next, similarly volume by volume is volume by volume percentage, that is volume of the component. Volume means obviously that is in terms of ml or milliliter or liter, divided by total volume of the solution. Suppose I am adding 10 ml of ethanol in 90 ml of water, that is volume by volume into 100 percentage. Okay. So next concentration term is your weight by volume. This is very easy. We are using in our pharmaceutical industries, in labs also. That is weight by volume, that we are taking the mass, the solute in mass, and we are adding in liter. That is, I have given that first example, that is gram per liter solution. Whatever we are doing during our distempering, we are adding some calcium carbonate into the water and we are mixing it while we are making some solution, sucrose solution, glucose solution. This is what our W by V, that is weight by volume solution. Here mass per unit volume. Okay. Next is molarity. That is also one term. Molarity. What is this? Remember R. Molarity. The number of moles of solute. Right. The number of moles of solute divided by volume of solution in liter. Remember, volume in liter, total volume. If I am adding, if you are taking 10 ml of ethanol in 50 ml of water, then the number of moles of solute that you need to calculate and the volume of the solution must be 60 ml, because solution must contain solute and solvent. That's why written volume of solution, not solvent or not solute. So what is molality? There is not big difference, but you have to know the silly difference. What is that? The number of moles of solute, the number of moles of solute divided by the amount of solvent in kg. What is the difference between molarity and molality here? Molarity is volume of solution in liter, whereas molality is amount of solvent in kg. So now you can say which one is better, molarity or molality? Obviously molality, because it is temperature independent. Am I clear? Is there any doubt? Okay, so in NCRT, the homework for you guys, NCRT example 2.1, 2.2, 2.3, and in text questions 2.1, 2.2, 2.3, 2.4 and 2.5. Make it ready and post in the group whether you have done or not. I'll check. Thank you.